Okay, so this is my first time of getting permission to create a makeup test review. A normal day, I don't normally create makeup test review. I just create the normal test review and the exam review. After we go, I'll create the exam review. Then I'll create the test review before the exam so you can use to prepare. But this is the first time that I got permission or I even knew that I could get permission to use makeup test. But I felt the makeup tests were, their backup question. Like maybe they have a question vote where they keep plenty questions. And then whenever you are going for makeup test, you usually get access to the back end question, the question that the like the pillar of all their questions, where they generate their many questions from that kind of thing. So I never even bothered to like ask for permission to use it. But then all of a sudden, they just asked me, I've created test one review for this course. Am I not going to create test two review? I said I've created test two review. And I said, okay, but are you not going to create the makeup test review? I said there's makeup test. I never even knew that you wrote makeup test. And even if after I wrote makeup test, I didn't know that I can ask for permission to create the makeup test review. So now say yes, I can, make it that they don't, mind. They've never actually minded all this time. And though a lecturer per se used to mind, but like most of them, they are chill about it. They don't really care. But I still just ask for permission for formality. Anyways, this video, I'm supposed to do it before the exam, but as I said, I didn't know that I would get permission to make the video. That's why I'm doing it now. So next year, the people that are writing coming to school university next year, they can see this video and find it helpful, useful in their preparation for exams. And I hope it actually comes in handy for them. I'm just trying to make sure that everything is working. Yeah, I don't know if you heard that, but that confirms that everything is working. So I'll just put this phone on charge and keep my laptop charger ready in case the laptop is about to die. So I can easily switch and put it back on charge. Put it on charge, so I don't put it back on charge. Okay. I think this basically all. That's what I need to do. Let me go through this question again to see in case there's anything. I don't think I had a problem solving this makeup test. Okay, let's go. Now, I just want before I begin, I just want to start with I've not actually seen the marking guide of this exam. So it's possible that you can get everything exactly how I got it and you still not get the full mark. Now, what do I mean by that? Because we all know that maths on its own is versatile. That is, it's not possible for two people. It's possible though, but like it's hard for two people to solve a question and get two different answers, and both of them are correct. You understand? There's only one correct answer to a question. Good. But I think that there are some, whenever it comes to OBJ questions or exams in general, it is if it's not a standardized exam, or this exam is a little bit standardized, but like if it's not an exam that has a governing body, that has like a full team of people. Yeah, there's a full team of people, like I said, if they make mistakes, there's nobody to caution them, there's nobody to, you know, put them down and say, oh, you made a mistake here, you understand? Whatever them they say is correct is correct. So it's not really like a standard exam. Like the SAT now, SAT come out and bring out question like 1 plus 1 is equal to what? You know that kind of question is not possible. Or they tell you x equals to 1 plus 1, simplify x just equal to 2, you understand? So you cannot say that kind of question because there's standard, but there's both that's kind of like that regulates the kind of question that they push out. But since this is a school exam, the lecturer can actually decide to ask you what shirt I wear this day. I don't know if you get what I mean. Though for maths, we hardly see that, but for English, you can see that kind of question. Now, for maths, even if they ask you a very hard question, there should still be one answer, right? But let me just hold you there. What if I ask you a question, what is the square root of 1? And I tell you option A plus 1. I tell you option B. Or no, not plus I just tell you option A 1, option B minus 1, option C 0, and option D none of the above. You see? As what square root of 1, option A is 1, option B is -1, option C is 0, option D is none of the above. Now, for me, it's actually a debate. Most people used to argue it that the square root of x is it going to be, or the square root of x squared is it going to be plus x or negative x, right? Now for me, the square root of x always goes with the positive one. So the square root of x squared is positive x when x is positive. The square root of x squared is negative x when x is negative. So at the end, the negative and negative cancel out, giving you a positive. So basically, the square root of x squared is equal to the absolute value of x. But in the, if you look at this question now, there's plus one here, and there's plus and there's negative one. Now, since we know in mass, the thing should be plus one because that is positive, right? Then we're going to go with option A. But what if your lecturer, right, wanted it in the form of, like, the way he generated the question was asking the question, if x squared is equal to 1, then that means x is going to equal to the square root of 1. In this case now, the answer is going to get not just going to be plus 1. The answer is going to get the plus, the positive and the negative answer. It's going to have the positive 1 and negative 1. Because if you plug in 1 plus 1 here, you're going to have 1. And if you plug in negative 1, you're going to have 1. So you can see, if your lecturer using his own style of reasoning, he will get D, none of the above, and not A plus 1. So that's why you have to attend lectures. See the kind of lectures, the lectures you're dealing with, and understand them. Another example, you have to get permission from your parents to, you understand? You have to get permission from them that you show on this video. Or this is live, like I cannot delete any part, you understand what I'm saying? Okay. But your voice, I don't think anybody cares around, like you can see whatever you say. Okay. So that's why you have to attend lectures to understand the reason of your lecturers, to understand what they're expecting you to do. Now I want to give another example, because this example actually did not affect me because I end up seeing that mistake, and I made the lecture and I say, what of this? And I say, oh, the only reason I'm teaching this way is because of a specific reason. Now, if you are doing MTH 111, you would remember that when he asks you to simplify a polynomial, they will tell you put it from the highest to the lowest, right? You can't remember that. Now let me give an example. Let's say we have 1 minus 2x minus x squared. So from their logic, you should put it from positive, from the greatest one to the lowest one. So you're going to have negative x squared minus 2x plus 1, which is correct. Negative x squared minus 2x plus 1 is correct. But they also say that in case the greatest answer is negative, that you should multiply the whole thing by minus 1. So the correct answer for them is going to be x squared plus 2x minus 1. You can see that this polynomial would give a different result than this. This polynomial will be curved up. This polynomial will be, I think it will curve down. Yeah, it will curve down, while this one will be curved up. So they're giving you two different polynomials, but this one, what they will pick as the correct answer. Now, when I made them and I said, but multiply by negative 1 totally spoils the whole thing. It changes the whole polynomial entirely. But he now told me that no, the reason why they asked us to multiply by negative 1 is because they understand that some people, they're not really good at maths, right? No offense to those people. They're not really good at maths. And whenever they ask them to solve maybe completing the square method, instead of making the x squared like have a coefficient of plus 1, just because the x squared was negative before, they'll leave it as negative 1. So in their own mentality, they're expecting that, okay, the right hand side will be 0. If the right hand side is 0, then multiplying by negative 1 would not affect your method of getting the what do you call that thing? I think getting the solutions of the quadratic, that is the quadratic solution. Yeah, when the polynomial is equal to 0, yeah, it's not affected because of, the right hand side is already 0. So multiply by negative 1, it will give you the same 2 points. Let me explain that with this graph. Okay, I'm filling it in this marker. Let me explain what I'm trying to say in this graph. Now let's say we have this polynomial like this for the one that is negative, for the one that is positive, sorry, and we have this one for the one that is negative. You can see that the points where they meet to the x-axis is the same. Good. So you're finding the points where the polynomial is equal to 0. It will not change your value because they are hitting at the exact same point. The only thing that it changes is it changes the whole polynomial, but it does not change your answer because it hits the x-axis at the exact same point, as I said. So when they are teaching us to multiply by negative 1, what they're actually making us, the main reason they're making us, just for that thing, please. The main reason that I'm making us do that is to help those people that don't really understand maths like that, so they can get the solutions of the quadratic question. It's not that they are going to say that, okay, now that I multiply by this one, plug in x equals to 1. No. They only plug in x equals to 1 when that x equals to 1, by the time you plug in x equals to 1, it's going to give you 0 as your final answer. Now, the actual way that this should be, ignoring what they've taught you, but as I said, do what they taught you. You're supposed to use the method that them they taught you. But the actual way, I felt it would have been better, and I actually asked them that, wouldn't this method better? Was if it's negative here, you pull out the negative one, open a bracket, you have x squared plus 2x minus 1. You can see in this way, you get their exact same answer that you want you to get, and it does not really affect the polynomial. This is the exact same polynomial. You put out the negative one, then divide the whole polynomial by negative 1. So you have the exact same polynomial. But I don't really know if they would hear me and change their method of teaching, or they will leave it as it is. But anyways, that's 11 minutes of introduction. I want to say thank you to my uncle for allowing me to. That's not actually have permission, but I believe they will not. They have the problem of me recording video. But I also thank God for the end of semester. I pray that more gives me the grace to cover more years in my life. That kind of thing. Anyways, let's get into the video. We have MTH 122 2025/2026 makeup test 2 review. Question 1. Question 1 is asks us to evaluate a limit. They say we should evaluate the limit of x squared minus 4 divided by x minus 2 as x tends to 2. Now, if you want to evaluate this limit, you first of all, you can just plug in your x into the function. If you plug in your x into the function, you're going to have 2 squared minus 4 divided by 2 minus 2. You can see already you're dividing by 0. So we're not like this, this will not work. But let's just continue. So this is going to equal to 4 minus 4 is divided by 2 minus 2. This is going to equal 0 divided by 0. This is an undefined point. If it was just this divided by 0, then it could be infinity and just be answer as infinite. But since you have 0 divided by 0, you're having an undefined point. It can be any number. So we're going to evaluate this limit. Now, there are multiple ways of evaluating limits. You can ask me, I can do a video on that. But to evaluate this specific limit, we're going to factorize. So let's factorize. And I wanted this to focus on the board instead of adjusting his lens whenever I'm coming close. You should focus on the board. But I hope people will still be able to see what I'm writing on the board. So by evaluating this limit, we're going to have, or let me try and write bigger. We're going to have the limit as x tends to 2. Or if you factorize out x squared minus 4, remember x minus 4 is close to difference of 2 squared. And x squared minus 4 is going to equal to x squared minus 2 squared. You can see the difference of 2 squared. And how do you write the difference of 2 squared? X squared minus a squared is going to equal to x minus a times x plus a. In this case, a is equal to 2, so a equal to 2. So you have x minus 2 times x plus 2. So the numerator that we have here is x minus 2 times x plus 2. While our denominator remains x minus 2. Now, what do you do here? Since we have x minus 2 in the numerator and x minus 2 in the denominator, you can cancel them out. So now we have the limit as x tends to 2 of simply x plus 2. And if you have the limit as x tends to 2 of x plus 2, we have a new function. So we plug in our x equals to 2 and see what it gives us. If we plug in our x equals to 2, we're going to have 2 plus 2, which is equal to 4. So the limit of x squared minus 4 divided by x minus 2 as x tends to 2 is equal to 4. My graphic calculator is there, but I feel that will waste time, and I've already wasted 11 minutes for doing introduction. So let me just try and rush through this video. So this is equal to 4. So I wanted to graph it to show you how the limit actually works. Because at this point, where x equals to 2, you're going to have a break, an undefined point. But because of the limit, you can see where that point would have been if it was defined. That point will be 4. So you can just take it as 4, as if the formula is 4. But at that particular point where x equals to 2, there's supposed to be a break. But as I said, the limit, since you have values that are infinitesimally close to 2, like 2.000000001. You understand? So instead of erasing a whole chunk, where you're actually going to erase 2.00001, instead of doing that, you can just draw it as a continuous function, but keeping in mind that you are dividing by an undefined point at x equals to 2. So at that point, x actually the value of the function actually be 4, but there's supposed to like be an imaginary break. I hope this thing is focused on the board and not on me. Okay. So anyway, this is the end of question one, and I wanted to see if I can show you the question before I start solving. Since it may be hard for people to get the question, I'll try my best to create like an archive, maybe a website where you can get all the MTH mass pass questions. But anyways, this is question one, and that is option D. That's option D. Let's go to question two now. Question two asks us using logarithmic logarithmic in English, using logarithm, we should differentiate a function. But actually say using logarithmic, okay, using logarithmic differentiation, we should differentiate y equals to 2x plus 1 to the power of x squared to the power of x squared. So let's say our function y is equal to 2x plus 1 to the power of x squared. And so we should differentiate this. Now, them telling us that we're using logarithmic differentiation to differentiate is actually an expo. You know, it's actually an expo from them. Though it's not an expo because it's them that gave us the expo. But to make this question test if you know what you are doing, they're not supposed to tell you the method they are going to use to differentiate it. I know some people may say, oh, do not make it harder. No, you're not supposed to tell us the method of mathematics that are going to use to differentiate it. But anyways, since they already told you the method of they are going to use, that's what we are going to use today. And it's actually the similar method to use, and that's the method I was also going to use if they ask me that type of question. What I'm trying to say is that if you want to actually test if you know what we're doing, then like don't tell us the method we should use to solve it. Just give us the question. Yeah. But anyways, if you want to solve this using logarithmic differentiation, you are going to take the logarithm of both sides. So we have the logarithm of y is going to equal to the logarithm of 2x plus 1 to the power of x squared. Now, because of a rule in logarithm where the natural log of x to the power of a is equal to a times the natural log of x. Because of this rule in logarithm, I'm not going to really go into proof. If you want another video on that, you can ask me for that. But because of this property of logarithm, we can simplify this expression to equal to x squared times the natural log of 2x plus 1. So we have the natural log of y is equal to x squared times the natural log of 2x plus 1. Now we take the differentiation or the derivative of both sides. If we differentiate the natural log of y, you are going to have 1 over y with respect to y. Or rather, as some mathematicians are trying to crack joke say, with some disrespect to y. And this is going to equal to, now you want to take the derivative of the right hand side, we're going to do it by part, or no, it's not by part they call it. We're going to integrate, I think it's by part they call it. I'm not really sure. Is it by part they call it? No, the derivation by part. It's using the product rule in hand. Integration by part is the integration of product rule. Integration by part is the integration of product rule. But anyways, I'm going to use product rule for this. But when I call it integration by parts, you're going to see it in a few minutes. So we are going to differentiate x squared times the natural log of 2x plus 1. You are going to keep x squared constant. Don't pass here. You are going to keep x squared constant. Then if you differentiate the natural log of 2x plus 1, this will be times 1 over 2x plus 1 times the derivative of 2x. So that will be times 2. Now how do we get this far? As I said, since we are using the product rule, what is the product that we are seeing here? The product you are seeing here is x squared times the natural log of 2x plus 1. So we have x squared, which is one term, times the natural log of 2x plus 1, which is another term. So you are going to keep x squared constant, and that's what we did here. We are keeping x squared constant. they are going to differentiate the natural log of 2x plus 1. If you differentiate the natural log of x, you are going to have 1 over x times dx. But if you differentiate the natural log of 2x plus 1, you are going to have 1 over 2x plus 1 times the derivative of 2x plus 1. And the derivative of 2x plus 1 is just 2 dx. Look at it. If you have u is equal to 2x plus 1, then that means the u is going to equal to 2 dx. So we're going to just have 2 dx over here. So basically just product rule, then chain rule. It's product rule to separate this one and this one, then chain rule to solve the function of function here. So we have x squared times 1 over 2x plus 1 times 2 dx plus, don't forget your plus. You can see the reason why me I assume that it was going to be differentiation by parts, because we have that differentiation, we are going to have one term plus a second term. So now what's that second term? Remember we kept this constant and differentiated this. So now we're going to keep this constant and differentiate this. So now plus the natural log of 2x plus 1 times the derivative of x squared. If you differentiate x squared, you're going to have 2x dx. So that will be 2x dx. So this is our first expression. We have 1 over y dy is equal to x squared times 1 over 2x plus 1 times 2 dx plus 2x times the natural log of 2x plus 1 dx. What they are just find? They just find dy dx. So now you can say there's dy here and there's dx here. Let's bring them together. So 1 over y times dy over dx is going to equal to 2x squared divided by 2x plus 1. There's no need for me to explain this, but we have 2 times x squared, that's the numerator, and the denominator is 2x plus 1. The dx goes to this side, plus 2x ln 2x plus 1. The dx goes to this side. Don't forget, we are looking for dy dx and not 1 over y times dy dx. So we are going to multiply by y. If you multiply by y, you are going to have dy over dx is equal to y times 2x squared divided by 2x plus 1 plus 2x times the natural log of 2x plus 1. But don't forget, y is equal to something. Y is equal to 2x plus 1 to the power of x squared. So instead of dy dx equals to y times this, you're going to have dy over dx is going to equal to dy over dx is going to equal to 2x plus 1 to the power of x squared times 2x squared divided by 2x plus 1 plus 2x times the natural log of 2x plus 1. And that corresponds to option C. It corresponds to option C, even though this and this were flipped, because remember plus is commutative. So a plus b is equal to b plus a. So in option here, you know 2x plus 1 to the power of x squared times 2x ln 2x plus 1 plus 2x squared divided by 2x plus 1. So they just put this term in this term and this term in this term. But I say addition is commutative. So option C is the correct answer. Option A, B, D, and E are wrong. Let's go to question 2 now. Question 2 asks us to differentiate. We should differentiate y squared is equal to x squared ln x. Okay. Okay. We have question 3. Y is equal to x squared ln x. I literally just forgot like what I was doing. I was confused. What am I doing here sitting down? But then I just remember immediately that okay, wait, I'm doing a little bit here. Okay, we have y is equal to x squared ln x. And so should differentiate. Remember, we're going to use product rule again. So we have this term multiplying with this other term. So we have the derivative of y, dy dx is basically going to equal to, you keep x square constant. If you differentiate ln x, you're going to have 1 over x, plus you keep ln x constant, then differentiate x square, you're going to have 2x. So this will equal to x squared divided by x, and that just x, plus 2x ln x. This is our final answer. No more stress. So we have option A is correct. 2x ln x plus x. I'm seeing a pattern here. Every single time I do this derivative, they are putting my second term in the place of the first term and my first term in the place of the second term. So I don't know if it's mathematical to put the more complex one or the one that have natural log in front of the normal polynomial term. But anyways, nobody have told me anything about that, and I'm not actually be criticized or given a lower mark whenever I write my own this way. But anyways, as I said, math is quantitative, so a plus b is equal to b plus a. So option A is correct. The derivative of y respect to x is equal to 2x ln x plus x. But then this question, it took us too much a short time to solve. So let me see if I can solve it using another method. We have y is equal to x squared ln x. I want to experiment solving with the logarithmic differentiation. So let's take the derivative of both sides. We're going to have ln y is equal to the natural log of x squared ln x. And we know that rule in maths. Let's look at it. When you have the natural log of x squared, this is equal to 2 ln x, which is equal to ln x plus ln x. So you have a product, you can change it to sums. So since we have the natural log of x squared times ln x, we can just change the natural log of x squared plus the natural log of the natural log of x. Yeah, yeah, boy. Now let's take the derivative of both sides. If you differentiate both sides, you're going to have 1 over y dy over dx is equal to, differentiate this, you're going to have 1 over x squared. Differentiate x squared, you're going to have 2x plus differentiate ln of natural log of x, you're going to have 1 over the natural log of x. Differentiate the natural log of x, you're going to have 1 over x. Yeah, this that's the end. So you have 1 over y times dy dx is equal to 1 over x squared times 2x plus 1 over the natural log of x times 1 over x. Now let's multiply both sides by y. You're going to have dy dx is equal to y times 2 divided by x, because one of the x here will cancel with x here, plus 1 over x ln x. The y here is equal to something. The y is equal to x squared ln x. So you're going to multiply that all through. So this is going to equal to 2 times x squared ln x divided by x plus 2x squared, sorry, plus x squared ln x divided by x ln x. Now if you simplify both sides, you're going to have x here will cancel out square here. So this is going to equal to 2, put this up, going to equal to 2x ln x plus x. Because x ln x here will cancel out x ln x here, leaving us with x here. So we have 2x ln x plus x. And this is exactly our answer to the previous question. So you can see in maths, as long as you are following doing the right thing, you are going to get the correct answer. There is no one fixed method to solve a question. That's why I said in that beginning that they shouldn't have told you the method to use. Because now, what if somebody don't know the logarithmic, what if somebody don't know the log differentiation? They will not be able to solve that question because of the battling, which one is log differentiation, which one is log differentiation. But they might even know that they're supposed to take the natural log of both sides, but because they know that that was the name, they will not be able to solve that question. That's why it's better to just leave it like that. Let people experiment, let them solve their beautiful ways, because maths is not fixed. Unlike some football matches, maths is not rigged. So maths is versatile. It can, answers can, solutions can vary. That's the beauty of it, and that's all of it. So we have the same answer, 2x in x plus x, and that's option A. So let's go to question 4 now. Question 4 says, given the implicit equation x squared y plus y cubed is equal to 10, we should find the derivative at the point 1 over 2. Before we find the derivative, we're going to have the derivative function, and let's find what that is. So we have x squared y plus y cubed is equal to 10. If it was possible for us to write this in terms of y exclusively, then we are not going to differentiate normally. But since it's going to be very hard or impossible sef, in some cases impossible to write this function exclusively in terms of y, that is y is equal to f of x. Y is equal to a function of only x. If it's impossible to do this, we are not going to differentiate this implicitly. That is, we are only differentiating with x and y living together. Now to do that, we are going to apply multiple product rules. Multiple product rules and multiple chain rules. But I'm not going to explain this because I've explained this multiple times. Multiple. But I'm just going to apply it. Okay. So we have a product here multiplied with another product here. Let's differentiate that. You are going to have keep x square constant, differentiate y with respect to x. The derivative of y with respect to x is simply just dy dx. So that will be x squared times dy dx plus keep y constant, differentiate x squared. So that will be y times 2x. Keep y constant, differentiate x squared. When you differentiate x squared, you are going to have 2x. So that will be y times 2x. So that will be 2xy plus differentiate y to the power of 3. If you are differentiating y to the power of 3 with respect to x, right? Remember, you are not differentiating x with respect to x. You are differentiating y with respect to y. You are differentiating a function of y with respect to y. So after you do that, you are now going to multiply by dy dx to cancel the dy. That is, you are differentiating a function of y with respect to y. That's what you are doing here. But to make sure you have the derivative of this with respect to x, you are going to multiply by dy dx. Because mathematically this will cancel out, leaving you with the derivative of f of y with respect to x. And this is what we are looking for. So you are going to first of all differentiate this with respect to y, then multiply by dy dx. So if you differentiate y cube with respect to y, you are going to have plus 3y squared. Then don't forget, as I explained, you are going to multiply by dy dx. This is equal to what? 10, right, is a constant. So if you differentiate a constant, you're going to have 0. So be equal to 0. Okay, I think that's clear. Okay, so now let's simplify this. Let's bring this dy dx and this dy dx together. So you're going to have x squared plus 3y squared times dy dx plus 2xy is equal to 0. This means that x squared plus 3y squared times dy dx is equal to negative 2xy. This means that dy dx is equal to negative 2xy divided by x squared plus 3y squared. Now these are our differential function. These are derivative function. Or you can actually this actually can actually be called a differential equation o. This is actually a differential equation because there is no constant. This actually okay, there is actually a constant here minus 2y and there is 3 here. So I believe okay, this is not the final part of the differential equation but it actually looks close to it. But anyways, you have this differential function here. They have to find at a particular point. They said at limit 1 comma 2. So now at the point of 1 comma 2, that means x is equal to 1 and y is equal to 2. So you are going to put what we just found out into our function. If you put that into our function, you are going to have minus 2 times 1 times 2 divided by 1 squared plus 3 times 2 squared. Okay? Minus 2 times 2 is equal to negative 4 divided by 1 squared, that is 1, plus 3 times 2 squared, that is 4. 3 times 4. And 3 times 4 is just 12. So that will be 1 plus 12. So this will be equal to negative 4 divided by 13. And that corresponds to option B. Negative 4 divided by 13. Okay, we finish question 4. How many minutes is that? 20, 35 minutes. Okay, now we can actually finish in 1 hour. Question 5 now say we should approximate. If y is equal to the square root of x, use differentials to estimate the approximate change in y when x changes from 9 to 9.06. Now there's usually they say approximate change. It's not give you the exact value, but it give you an answer that is very close to it. If your change in x becomes bigger, the accuracy of the answer will become smaller. So no. If your change in x becomes bigger, yes, the accuracy becomes smaller. That means it becomes less accurate. Yeah, basically. So if your change in x becomes smaller, the accuracy becomes bigger to the point where it can actually be 100% accurate. It's 100% accurate when your change in x is epsilon. That is, it is so small that its square is equal to zero. That is, epsilon square is equal to zero, but it is still so big that it is greater than zero. Good. Basically, we have epsilon is greater than zero, and epsilon square is equal to zero. So it's so small that the square is equal to zero, but still so big that it's greater than zero. So you have y is equal to square root of x. Now how do we approximate this? I'm not going to use first principle, but using first principle is what I can actually use to show this. But I'm not going to use second principle to differentiate this. With differentiate both sides, you're going to have dy is equal to this is equal to x to the power 1 over 2. So you bring down the power 1 over 2 times x minus 1 over 2 dx. You can simplify this as 1 over 2 times 1 over x to the power 1 over 2. You can simplify this again as 1 over 2 times 1 over square root of x. You can simplify this as 1 over 2 root x dx. So this is the simplest form, and this is what we're going to use. So I'm going to clean up this up here and just write dy is equal to 1 over 2 root x times dx. Now if you are changing this from continuous to discrete, the integral sign, the integral function will change to summation. Dy will change to change in y, dx will change in y, change in x. That's basically all. So let's change this to discrete. That means the change in y is going to equal to 1 over 2 root x times the change in x. This is what we're looking for. Now what's our value for x? They say x changes at when is equal to 9. It changes from 9 to 9.06. So the first value of x is equal to 9. Then your change in x is equal to 9 minus, or rather, yeah, you can either put that is the absolute value of 9 minus 9.06, which is equal to the absolute value of negative 0.06, which is equal to 0.06. We're already dealing with the positive one. So now let's put what we found now into our function. Put that into our function, you're going to have the change in y, which is what we're looking for, is equal to 1 over 2 times the square root of 9 times 0.06. Square root of 9 is equal to 3. So this is 1 over 2 times 3, which is equal to 1 over 6. So this is 1 over 6 times 0.0 times 0.06, which is equal to 0.01. And this is our correct answer, option B. Option B states 0.010. The 0 is insignificant, so this is our correct answer, option B. So now let's go to the next question, question 6. Oh. Question 6 asks us to find, okay, we should find the local minimum that this for this function. Now let me explain local minimum. This is a cubic function. So we are going to have a function like this. This will be our local minimum. The actual minimum value is down here because these values are less than this value. But these are local minimum because of the values that are around it, not these values that tends towards infinity. The values are around it. This is the least one, this is the minimum one. So this is our local minimum. This is our local maximum. This is our global maximum, and this is our global minimum. Because globally this is our lowest value, globally this is our maximum value. Locally this is our minimum value because the values are around it. This is our minimum value, and locally this is our maximum value. Yeah. Now how do you get local minimum and local maximum? If you noticed, I already cleaned the function, but let me do it again. If you notice at the local minimum you have this derivative, that is the tangent line is parallel to the x axis. That means the tangent line is has a gradient of 0. So dy dx is equal to 0. So if you look at it, the tangent line is this what they call it, this thing equals 0. And another thing I notice is that the gradient here falls. So the gradient moves from negative to positive. The gradient falls then rises. So for local minimum, which is what they ask us to find, for local minimum, number one, the derivative dy dx is equal to 0. Number two, the the derivative changes from negative to positive. Good. Now what else do we notice? We can also notice that here you have concave up. And whenever you have concave up, this gives us number three. The second derivative is greater than 0. So you can see this is basically the three things. You can get so I'm actually going to solve it using the two methods. I'll first of all solve using the first method, which is using 1 and 2. Then I'll now solve again using the second one, 1 and 3. We are solving using the first one. We need to find our derivative. You have y is equal to x to the power of 3 minus 3x squared minus 9x plus 5. You have x to the power of 3 minus 3x squared minus 9x plus 5. So let's find dy dx. This implies that dy dx is equal to 3x squared minus 6x minus 9 plus 0. But plus 0 is insignificant. So our derivative is equal to 3x squared minus 6x minus 9. But remember they say that we are looking at the point when our derivative is equal to 0. Now when is our derivative equal to 0? Our derivative is equal to 0 when 3x squared minus 6x minus 9 is equal to 0. So now x minus 3 is equal to 0. You are going to have x3 is equal to 0. Minus 3 is equal to 0. This implies that x is equal to negative 1 or positive 3. That means one of these will be our maximum value, one of them will be our local minimum. X equals negative 1 or x equals to positive 3. So now we're going to use the first one. The derivative changes from negative to positive. So now, how do you find out if your derivative changes from negative to positive? You're going to use something called like a truth table. You're going to divide this into parts. You're going to divide our x-axis into parts. You have when x is less than negative 1. You have when negative 1 is less than x less than 3. You have when x is greater than 3. Just in case the next World Cup is going to happen soon, I'm going to actually leave you people. Oh my god, I started already. This is already this 8 o'clock. I'm supposed to be gone now, but let me just finish this quickly. I want to watch that match live, but let me finish this quickly. So you're going to divide this into parts. You have x plus 1 multiplied with x minus 3, and we have the product here. So when x, oh my god, mistake. And just in case, I'm actually supporting Argentina, so I hope they win. Okay, yeah. When x is plus 1, when you have x plus 1, when x is less than -1, then x plus 1 will be less than 0. So this is negative. When x is less than -1, x minus 2 will be less than -4. So this is negative. When x is between -1 and 3, x plus 1 will be between 0 and 4. So this is positive. When x is between -1 and 3, x minus 3 will be between -4 and 0. So this will be negative. When x is greater than 3, x plus 1 will be greater than 4. So this is positive. When x is greater than 3, x minus 3 will be greater than 0. So this is positive. The product is positive, negative, positive. Now we are looking at the point where the derivative changes from negative to positive. If you look at it from the negative axis, it changes from positive to negative, then from negative to positive. You can see this is the point we're looking for, where it changes from negative to positive. And it changes from negative to positive at this point when x equals to 3. Because here we have x is less than 3 and we have x is greater than 3. So it changes immediately at that point where x is equal to 3. And that is the point when our derivative is equal to 0, as you can see here. So our answer would be x is equal to positive 3. This is the first method using the first derivative test. Now let's use the second derivative test, which is actually much easier to use for this type of question. The second derivative test, you're going to differentiate our function again. If you differentiate our function again, you're going to have d square y over dx squared is equal to, differentiate that again, you're going to have 6x minus 6. If you put in our answers, we got x is equal to -1 and x equals 3. Put in x equals to -1, you're going to have -6 minus 6, that is -12. Remember, this is negative, but what we're looking for is greater than 0, so we're looking for positive. So we're going to put in our second point when x equals to 3. When x equals to 3, you're going to have 18 minus 6, which is plus 12, positive 12. So this is what we're looking for, positive 12, and this occurs at x is equal to 3. So you can see using the second derivative test is actually faster than using the first derivative test, but we end up getting the same answer, x equals to plus 3 and x equals to plus 3, and that corresponds to option D, or option E, x equals to 3. They're not going to put plus 3 or -3, so x equals to 3, that corresponds to plus 3, option E. Okay, question 7. Question 7 asks us to integrate. Question 7 asks us to integrate 2x divided by x squared plus 5 with respect to x. 2x divided by x squared plus 5 with respect to x. Okay, that's doable. So I'm going to apply u substitution. Let u equal to x squared plus 5. If u equals x squared plus 5, then the derivative of u is going to equal to 2x dx. So now let's put in our function. Let's substitute. This will give us the integral of 2x dx, which you have 2x dx here, is equal to du, divided by x squared plus 5 is equal to u, so this is equal to u. So we have the integral of du over u, which is equal to the natural log of the absolute value of u plus c. So this is going to equal to the natural log of the absolute value of x squared plus 5 plus c. And this corresponds to option B, the natural log of the absolute value of x squared plus 5 plus c. So let's go to option B now. Let's go to option B now. Now it doesn't really matter if you see absolute value or let's say you see the natural log of x squared plus 5 plus c. You can actually go with the one that has brackets. They are not basically too different. But just now absolute value is the correct one because the natural log cannot have negative answers. That is, you cannot have the natural log of negative one. Most of you only accept positive numbers. In fact, it does not accept zero. There's no natural log of zero except in the imaginary plane. There's no real natural log of zero. So can specify that it is greater than like absolute value is greater than positive, it's greater than zero. Okay. So let's go to the next question. I'm always late. I'm always late for this work. And this is the final. I wanted to be early for this one. But this is almost 1 hour, so I think I can finish this in 1 hour 30 minutes. Question 8 now says we should find the integral of x times e to the power of x dx. Now, if you want to find this integral, it's not really that complex or that hard to evaluate. We are going to do the integration by parts here. And since we have a linear function that can tend towards zero, we are going to differentiate this and integrate this. So we have let u equal to x. This means that u is equal to dx. And let the derivative of v equal to e to the power of x dx. This means that v is equal to e to the power of x. Yeah, because if you differentiate v equals e to the power of x, I'm going to have v is equal to e to the power of x dx. So now let's put in this into our integration by part formula. We have the integral of u dv is equal to uv minus integral of v du. U dv is equal to x times e to the power of x dx. So you have the integral of x times e to the power of x dx, which is what we are given to solve. Which is what we are given here to solve for, is equal to u times v minus v du, where u and v are already seen on the board. So you can try that on your own. You actually put me inside army because how I see the way I'm reloading this thing fast. Tell me which army official can reload marker like me faster than me. You should put me inside army like this now, reload their gun fast fast, 2 seconds. Okay. Anyways, let's continue. We have uv minus integral of v du. U is equal to x times v, and v is equal to e to the power of x minus the integral of v du. So that will be e to the power of x dx. So the integral of e to the power of x dx is simply just e to the power of x. So our final answer, the integral of x times e to the power of x dx is equal to x times e to the power of x minus e to the power of x. And this corresponds to option B. Okay, let's not forget plus C, our integral constant. But then option B wrote it as e to the power of x times x minus 1 plus C, which is still correct. All you did was to factorize out e to the power of x. So you have e to the power of x times x minus 1 plus C. And option B is correct. Now let's go to option 9. Question 9, sorry. Question 9 says we should evaluate a definite integral. So we have the definite integral from 0 to 2 of 3x squared minus 2x dx. When solving definite integrals, you're going to just first of all solve it normally, like you solve normal integrals, then apply your limits. Let's solve it normally like you solve normal integrals. This is equal to x to the power of 3. Actually, it's equal to 3. But the 3 here will cancel out the 3 here. So we just have x to the power of 3. Minus 2x squared divided by 2. The 2 and 2 will cancel out, so you just have minus x squared. And not forget we're integrating from 0 to 2. So now let's apply our limit. We have upper valuation minus the lower, upper, okay, minus the lower valuation. The upper is 2, so we have 2 to the power of 3 minus 2 squared minus 0 to the power of 3 minus 0 squared. 2 to the power of 3, this is 8 minus 4 minus 0. This equals 8 minus 4, that is 4. 4 minus 0, that is just 4, so we have 4. And that corresponds to option C, 4. So now, that being the end of this question, let's go to question 10. Question 10, final question. Asks us to evaluate using partial fraction. And them telling us to evaluate using partial fraction is actually an expo. You know, they can just have they can just set question like that. But anyways, if you don't know what to use, let's use it. So we have the evaluation of 3x plus 5 divided by x squared plus 3x plus 2 dx. Solve this using partial fraction. To solve this using partial fraction, you are going to separate them into their component parts. That is, when you have, let me try to do that, plus 3x plus 2. So this will equal to a divided by, if you factorize this, you are going to have x plus 1 and x plus 2. You can tell you something yourself. That's why I'm just going to the correct one. So you have x plus 1 plus b divided by x plus 2. Now, if you solve this partial fraction, you are going to have a is going to equal to 2 and b is going to equal to 1. So 3x plus 5 divided by x squared plus 3x plus 2 is equal to 2 times, is equal to 2 divided by x plus 1 plus 1 divided by x plus 2. You can attempt partial fraction by yourself, I believe so. So there's no need for me to solve the whole thing because I really need to go and watch match now. So this is going to equal to the integral of 2 divided by x plus 1 dx plus another integral of 1 divided by x plus 2 dx. So this is going to equal to 2 times the integral of 1 divided by x plus 1 dx plus the integral of 1 divided by x plus 2 dx. So this is going to equal to 2 times the natural log of x plus 1 plus the natural log of x plus 2. Don't forget our integral constant. And this corresponds to option B. 2 times the natural log of x plus 1 plus the natural log of x plus 2. Option B. And this absolute values actually it looks confusing. You can mistake it for the natural log. That's why I like using brackets. Whenever I'm solving on my own, I like using brackets. I avoid confusing myself. But like whenever you're solving an exam, use the absolute value. So you have 2 times the natural log of x plus 1 plus the natural log of x plus 2 plus c. So this is our final answer. This is the end of this exam review. Okay, I'm not going to reach 1 hour yet. So I'm going to end it exactly at 1 hour. So thank you for watching. Thank you for coming. I hope you learned something today. Please have any question, please ask me. Thank you so much. See you on the next one. Bye bye.